Well, good evening, and welcome to the New England Aquarium Lecture Series for the spring 2018 season. My name is Brian Scarry, and I'm a trustee and the Explorer in Residence here at the New England Aquarium, and a photojournalist specializing in ocean wildlife. And I have the great pleasure to introduce your speaker for tonight, Dr. Scott Kraus, the Vice President of Research at the New England Aquarium with over 40 years of field research and scientific publication experience. 40 years, you've been doing this a long time, yeah. Gotta get a real job, yeah. Generous support from the Lowell Institute allows the aquarium to offer these programs free of charge, and we're grateful to have that support every single season. We ask that you please silence your cell phones until the end of the event. This lecture, like many others, are available on the New England Aquarium YouTube channel and on WGBH's forum network that you can share with your friends and family. So now, a little bit about Scott. We'll keep it professional. Scott has indeed been a research scientist at the Aquarium's Research Laboratory since 1980 and has published over 110 papers. Think about that. 110 scientific peer-reviewed publications on marine mammals, bluefin tuna, harbor porpoise, fisheries, and bycatch. Scott is probably best known, though, for his work with right whales. And he's worked on the biology of the North Atlantic right whales since 1980, since he began here at the aquarium, publishing numerous papers on right whale biology and conservation. He's also the co-editor of a really great book. If you haven't seen it, it's called The Urban Whale. It was one of the first books I looked to when I began doing a story on this subject years ago. It was published by the Harvard University Press in 2007, and it's about right whales of the North Atlantic. He was a member of the original U.S. National Right Whale Recovery Team, and he currently serves on the U.S. Large Whale Take Reduction Team. He's also a member of the research faculty at UMass, the University of Massachusetts here in Boston. His recent projects, Scott's recent projects, have included studies on the distribution and abundance of marine mammals and sea turtles around proposed wind farm sites, methods for reducing incidental bycatch of cetaceans in fishing gear, exploring visual capacities of cetaceans, and investigating the oceanographic underpinnings of marine mammal concentrations in the New Atlantic Canyons and Seamounts National Marine Monument, a very important site, the only protected place in the Atlantic on the Atlantic coast of the United States, and currently under threat. On a personal note, I want to mention that, I've had the privilege of working with dozens of great researchers throughout my own career, and I couldn't do what I do if it weren't for researchers. But few possess the many talents of Scott Kraus. Scott is brilliant. He's dedicated his life to not only understanding the science of specific species like right whales, but also understanding how multiple species interact within various ecosystems. He's also been an articulate spokesperson for conservation, something that not all scientists do, but I believe is very important. And he uses scientific data to sound the alarm for these animals that are in peril, like right whales. And perhaps most important is that Scott also has spent his career searching for solutions and is able to sort of bridge the gap between the fishing communities and the science communities, the conservation communities, to find common ground and to move those solutions forward, which is really what we need. The ocean is in great trouble. There's a lot of problems out there that most people don't really understand. And before we can move ahead, we have to understand the problems, we have to have scientific data to support that, and then we have to find those solutions. And Scott Kraus is one of those rare individuals who's been able to bring together all of those things, the perfect trifecta. So please welcome Dr. Scott Kraus.
Thank you, Brian. I'm totally embarrassed. So I've been chastised by some colleagues for not defining my terms enough, and I want to do that right off the bat. Not everyone is aware of the term Anthropocene, but if you think about dinosaurs and the Pleistocene and that kind of stuff, the Anthropocene is generally defined as that period of time, which we live in now, in which humans actually dominate the characteristics of the planet. There's both terraforming and changing the shape of the planet, and there's changing the ecosystems and changing the characteristics of the places where animals and humans live. So that's my little definition, and I wanted to discuss, I'm going to use right whales tonight as an entree to this entire discussion about what extinction means and why we should be worried about it. So there are lots of ways to go extinct. You know, and most of you will be familiar with this at some level, that you could have a body part that's an aphrodisiac. That's a really quick way to go extinct, and not a very pleasant one. And then you could be in the way. You could be in the way of suburbia or development, loggers, miners, farmers, or just about any other human activity. Another bad way to be in the world is if you're good to eat. So that would be a pretty quick end. And you can be in competition with humans, and we've seen a fair bit of that in different parts of the world. The terrestrial examples are pretty well known. They get a lot of support. People actually get it when these big animals go extinct. But marine mammals are not really much different. You know, there's industrialization. We develop a lot of pieces of real estate in the ocean. There's fisheries, oil drilling, seismic exploration, habitat destruction, hunting, poaching, et cetera, et cetera. And it doesn't really matter the size. If you're in the way of civilization, bad things have happened in the past. If you look at and it's also a problem if you live in a restricted area. So for example, the Baiji in the upper right-hand corner live just in the Yangtze River in China, and that river is one of the most heavily industrialized rivers in the world, and so you're not going to do so well in there. There's a lot of fishing, a lot of shipping, boating, a lot of activities there. So that's the kind of circumstance that many of these marine mammals have found themselves in. The thing that's interesting, this is a little dolphin called the vaquita, found in the Gulf of California. And most people don't realize that these extinctions happen really fast. So the graph there shows that the Baiji basically has gone, the vaquita has gone from over 500 animals in 1997 to less than 30 in 2017. And now we suspect that it's half of that. And so that's 20 years in which this animal is pretty much gone. And if we look back at the Baiji and the Yangtze River, that was about 30 years since the early warnings that the population was in dire straits. And notwithstanding the heroic efforts of Mexican and U.S. scientists and managers, you know, there's just not enough vaquita left in the wild to present a viable option for the future for that population. And it remains an open question, even if you could capture them and breed them and so on, whether you would have an ocean that you could put them back into. So there are other marine mammal populations at low numbers, and I thought people are unaware of them. They don't have any press. They don't have any studies going on in a big way. There's a little whale. It's a big whale. It's actually in the Brutus whale clade. So it's about 50 feet long that lives in the Gulf of Mexico and nowhere else. And there are only about 30 of them left. And the Gulf of Mexico, as you know, is ground zero for a lot of exploration for oil and gas. So they picked a particularly bad place to hang out. The North Pacific right whale is estimated on the eastern side of the North Pacific, so that is the Alaskan sort of Aleutian side, is estimated to be about 35 animals. There may be more of them on the Japanese and Russian side, but we don't have any good surveys out there. In the Arabian Gulf, there's a group of humpbacks that do not migrate, and there's only about 80 of those. There's a little whale called a Mura's whale, also in the Brutus whale clade, so it looks like a little fin whale. Lives in Madagascar, estimated size 200, 300 animals. In the Sakhalin Islands, off of Russia, there's a group of gray whales estimated between 80 and 150. There are a lot of riverine and estuarine dolphins for which there are subpopulations or populations that are extremely small. And of course, there's always coastal dolphins, which those populations get fragmented up by industrialization and ports and things like that. So a lot of animals, marine mammals, that are actually at very low numbers. That is really depressing if you think about it too much. So we're not going to think about it that way. And I think it's important for us to think about how we can collectively change the trend lines toward extinction. So for nearly 40 years, I can't believe you actually said that, but anyways, my mother still hopes I'm going to get a job. I've been working on North Atlantic right whales, and this is a species that was probably on the brink of extinction. I mean, literally less than 100 animals in the early 1900s. They were consistently hunted by whalers from about 900 AD through the 1720s. And by that time, the North Atlantic right whale was brought to near extinction on the western North Atlantic. And however, they were so valuable that the whalers, even though they were going off to hunt for sperm whales and humpbacks and bowheads and other things around the world, if they encountered a right whale, they would continue to take it, lower the boats and kill one. We think that the population may have only been, perhaps 50 whales in 1900. And it came back very slowly over the last 100 years to about 500 whales in 2010. And we are now looking at the 7th year of a population decline that's quite precipitous. And while the reasons for that are pretty well known, the solutions are quite complicated. And because right whale management is so challenging, I've been thinking about the difficulties of marine conservation generally and wondering if we could do better about this. And I have these are the things that I've been thinking about. In many people's minds, the issue of whale conservation is kind of irrelevant. As many people know, the Greenpeace saved the whales 40 years ago by driving small rubber boats in front of big, bad harpoon ships, right? But the very real threats today are more about humans using the ocean for industry without understanding the consequences of that kind of development. And for us to succeed at saving the oceans from ourselves, we need to understand that marine wildlife and ocean health are important, even critical to our own well-being. And because marine mammals are my expertise, and because they have a big charismatic head start over things like sea cucumbers, for example, I'm going to use whales and dolphins as examples. So my thinking on this has boiled it down to about 4 questions. The first one is, why do whales and dolphins, and for that matter their homes, the oceans, matter? Because a lot of times people just assume that everybody loves whales, and so you don't need to ask that question. In fact, you need to ask that question and you need to defend it. How can we tell when populations are collapsing in order to give us time to intervene? And that's actually the way we prevent extinction, if we can figure it out. What kind of home do whales and dolphins need to thrive? We have a lot of definitions of critical habitat, but most of them revolve around food and don't tell us much about what else they might need. And what can we do to make our industrialization or development of the oceans more sustainable and benign? So I'm going to go through these one at a time, and I apologize in advance for geeking out on some technical stuff, but it's my right, so you're out of luck. So why are whales important and why should we care? So here's an interesting thing that almost no one knows about. Whales are accidental farmers, and the way they do this is they generally feed at depth, and they eat a lot, right? If you weigh 50 tons, you're going to eat a lot. And they tend to poop at the surface. Yes, that picture is a poop on the left-hand side. It is the way the world goes round. I know that you didn't know that, but anyways, so they're eating at depth, they bring the stuff to the surface, and they're fertilizing vast swaths of ocean. Whale poop supports fisheries in healthy oceans by transferring energy, nitrogen, iron, and nutrients from the deep ocean to the surface. And the subsequent productivity is critical to food chains that support all the fishing industries and a variety of other things. Further, that kind of iron fertilization at the surface also is a way in which we can inhibit climate change, because when iron is the limiting factor in plankton growth at the surface of most oceanic areas. And so if you have a lot of iron coming into the surface, you get a lot more plankton, a lot more carbon is absorbed and deposited then in the deep sea. So imagine that, they support fisheries and they prevent climate change. And if you have hundreds of thousands of whales swimming around doing that, it's actually pretty good for everybody. And this is not really a belief system or some propaganda. As these publications show, these are the facts. And it's essential that we get this story to people and to fishermen and to politicians and managers and the general public. I think this is one piece of the story about why whales are important. The second thing that we should think about is that there's a lot of recent work that shows that whales and dolphins live in these societies with families, genealogies, social interactions, histories, and culture. And this is kind of new for people. People know this about like the chimps of Gombe and the gorillas in the African forest. And we know a little bit about it in some other populations of mostly primates, but we don't think about it so much with whales. The humpback whale singing, everyone thinks, oh, this is great. They're like birds. In fact, they're much more sophisticated than most birds. They pass information on to one another, interact in complicated and sophisticated ways, and they communicate and travel on scales that boggle our little terrestrial minds. So this isn't some new age fantasy. I'm not out here, going and talking to the whales. These are the facts, and this is not a judgment about their intelligence either. The animals have evolved into this very extraordinary, complicated social structures throughout the ocean, throughout multiple species. And people can relate to social animals because really they're not that different from us. And by extension, we can start to relate to their home, what the oceans need. So the second question is how we assess these small populations. And this is, sorry, I'm going to geek out here a little bit, but we currently use data from sightings and surveys to tell us how many there are and how many are born and dying each year. And it's important to improve these population assessments because most managers depend upon them to make assessments about what they should be doing, right? But with small populations, it's exceedingly difficult to actually measure the total number of animals and what the trend lines are. The sample sizes are small, the statistical approaches are very shaky, and it's a rare day when you can detect a trend in less than 10 years. And for very small populations, you don't have that kind of time. Given the speed with which bad things can happen to these small populations and the slow response times of management, there's really no scientific justification for ever allowing the removal of any animal in a population less than 500 animals, because things will happen bad quickly. And when populations fall below that, then my feeling is that we should be falling back on the first principles of biology. We have a bunch of tools that, if they're used appropriately, give you much better power to detect rare species problems long before they become statistically robust in terms of absolute numbers. So, for example, health assessments. Most people can tell when their dogs or their cats are sick or off their feed. And really, it's just a question of learning enough about marine animals to know what the signals are. Here at the aquarium, we've developed a bunch of methods to look at health assessments of large whales to create a better understanding of what's going on with them. And it's now, I would say that it's now being used in a variety of species around the world, and it's pretty much considered mainstream marine mammal science. And what we've done with this is converted multiple visual measurements, including how fat they are, how good their skin looks, whether they have certain parasites, into a score of 1 to 100, with 100 being the best. And that score can be linked to events throughout a whale's life, including birth and illness, entanglements, ship strikes, those kind of things. So this provides us robust methods to evaluate the effects of human activities on whale health and the consequent effects on population trends. So why does that matter? I'll give you one example. Relatively small changes in female right whale health can influence reproduction. And the lowest health score in the right whale population at which any female is has calved was 67, suggesting that this is a threshold below which you're not going to have any babies. This is not surprising. Most mammals have comparable kinds of body condition indices that, if you're a cow or a deer or something, you go through a drought, you're going to stop reproducing. In this case, seriously entangled animals showed a continual decline in health for a full year after the entanglement. And the kind of pink-red section there is that area below the threshold based upon the health assessment work. And the area above the green, in the green area, is actually is above the threshold, and those whales could probably have babies. So when we looked at what happens, I should say the left-hand side of this graph shows also the categorization of different entanglement events. So we classify them as minor, moderate, and severe. And what you'll see here is that basically when an animal is severely entangled, it never recovers, and basically it's always below the reproductive level. And that indicates that this will have a population impact. Another indicator of population's health, and it's related to the previous one, can be found in examining calving rates. And in right whales, the number of females available to calve has been increasing since the 1980s. In other words, they keep growing up and being ready to have babies. But the percentage of those females giving birth has been falling in the last 10 years pretty dramatically. The little red barred graph on the bottom there is the absolute number of calves born to the population each year. And you can see that between about 2001 and 2009, we actually did pretty well. Animals were producing at about 20 to 30 calves per year, a little bit lower than what we'd expect in a healthy right whale population, but pretty good. But over the last 7 years, you can see these things dropped off, and in 2018, there were no calves born. And so this kind of stuff does catch your attention. Now, I do want to say there have been a lot of doomsday sayers that say, okay, well, clearly they're not having any babies. We should just write them off. Don't worry about them anymore. They're gone. That's in fact not true. These whales can live to be 100 years, and their reproductive lifespan can be 40 to 50 years long. If you're going to be reproducing for 40 or 50 years, you could take 10 years off and nobody really worries about it, right? They certainly don't worry about it. So what you have to do while they're taking that time off and looking for the environmental conditions to change so they can get back fat and happy and start reproducing again, you can't kill them. That's the problem. Populations will decline if you don't pay attention to what's going on with calving. So there's one other thing that, there might be a couple things here, but there's one thing that is interesting, which is that most mammals have approximately equal numbers of males and females. It's skewed at different age categories in humans. Males never go to the doctor, so they tend to die earlier, you know, things like that. So you know what I'm talking about. And in right whales, we see something different, which there are increasing number of males versus females over time. And when population sex ratios skew like that, if they're consistent, that's okay. You would expect that to be part of the normal demography of a population. But when you see a divergence like this population sees, you got two possibilities. One is that it either means that females are dying at greater rates than males, or that somehow the females are producing more male calves than females. It could be both. It could be some combination. Either case is a little bit of a cause for alarm. And if this separation between males and females continues, it's not going to end well, because what you see happening there is that females tend, if you get less and less females, pretty soon you have nobody reproducing, and we got a bunch of old males swimming around the ocean. Finally, I think that monitoring mortality is critical. The examination of dead whales is actually an important link in understanding the status of any endangered species. Otherwise, managers are in the dark about what's killing off their animals and whether their actions or management strategies have had any effect at all. Here in the right whale story, we have had quite an increase in mortality, and this is statistically significant. But what's interesting is that the major cause has changed, and the reason we know that is because we've been taking animals apart on the beach for 40 years now to try to figure out what's killing them off. So now we know that, yeah, in the old days, that is prior to 2010 or thereabouts, most of the mortality was due to ship collisions. Whales are hit by ships a lot, and nobody really understands why, but we do know that it kills quite a few of them. And then after 2010, we started to see a big increase in entanglement kills, and that has persisted through the last couple of years. One thing to remember about this that is even more worrisome is that we only see about 1/3 of the animals that die in a given year. And that means that all of our assessments of the cause of death from human activities are minimums and probably widely underestimate the actual rates of death from all different sources. And you don't want to think about that too much, because those numbers could be quite high. But there are, in other words, these are the tools that we could use that are not based simply on counting the number of animals, because you never see them all. Whales die for long periods of time. So if you're in a boat or flying an airplane, you never see them all. So your counts are always challenged, and your assessments are always challenged by that kind of availability of animals. So these are the alternatives that I think need to be employed. The third question is, what is a marine mammal habitat? And this basically is the question that you would ask. Another way to put it is, what does a marine mammal need to have a good home. Surprisingly, most countries have defined critical habitat for marine mammals and for many other things on the basis of what the animals need to eat. So this is a little bit like building your house and only putting in the kitchen. I mean, actually, I would do pretty well there, but it ignores the places required to sleep, communicate, and the halls to get from one room to another. So we have ignored a variety of characteristics that exist in the ocean that marine mammals, who are entirely auditory, are dependent upon. And small populations of marine mammals will especially require more protection than just the kitchen. We need to consider their homes in their entirety to reduce the risks of rapid extinctions. And because many whales are migratory, we need to think about the migratory corridors between feeding, breeding, and areas between the different areas in different parts of the world. And one thing I'll say is that if you put yourself in the context of any large whale, let's say humpback, 50 feet long, okay? The average visibility in the Gulf of Maine is like 30 to 40 feet. So if you put that in the context of living, say here in Boston, that means imagine that you are able only to see about 4 feet in front of you all the time. And in that context, you have to find your way around. That would be a little bit of a challenge. So that's the circumstances that whales live in. And that's why they need acoustic systems to actually find their way around, find their mates, find their buddies, there's possibility of group foraging so that they actually communicate with one another over food. All of these things matter, and the communication space is one of those areas where we've significantly altered in it. I want to give you just a quick visual representation. This is from my colleague Chris Clark about the noise footprints from individual ships, just to think about this in a visual way. And I decided not to inflict the sounds of ships upon you. But a whale's acoustic space represents the distance over which a whale can hear and be heard. And the footprint is the space over which the sound from a single event, for example, the call of a right whale, the noise radiating out from a ship, and this is what's shown in this animation. The small dots are whales, and the large dots are ships traveling into Boston Harbor. I'll play it again for you. And when the voice of a whale disappears beneath the ship's acoustic footprint, that voice is lost in the nose. As a result of this research, Chris and his colleagues discovered that the cumulative impact of commercial shipping noise off of Boston reduces the opportunities for whales to communicate and maintain their social network by 63%. In other words, the whales have lost about 2/3 of their critical acoustic habitat as a result of commercial shipping alone. And we don't really need to go into the other sorts of noise that may be coming their way soon. Seismic exploration is even worse than this. So one can imagine that this is a challenge. The way to think about this is that better definitions of what critical habitat means for different species are needed. When it's where it's quiet enough for whales to hear one another, and it's where migration and foraging can occur without getting hit by a ship or entangled in fishing gear. In this animation, a lot of people ask, well, how do they get entangled in fishing gear? So I'm going to show you an animation that actually represents what we think is going on. The ocean habitat is three-dimensional, and anything that interferes with the free passage and communication in those three dimensions is an alteration of that habitat. And to claim that fishing gear or seismic exploration does not alter habitat is an argument of last resort. It doesn't really hold up. So we'll need to be more creative about habitat protection, and it may not mean absolute closures to human activities. Imagine instead an ocean where there are quiet and slow ships, where there's fishing without ropes in the water column, and aquaculture and wind farm sites that are benign, not impacting the habitat or the animals. And I will say that I am in favor of, complete favor of protected habitats like the Marine Monument, and because I think they have a place that's a little bit different than general oceanic protection. But what we mostly want is for ocean industries to have minimal impact and not to kill or disturb marine mammals in their habitat. Now, most people are a little bit challenged in understanding the concept of an industrial ocean. And to illustrate this, this is a map of the continental shelf of the western U.S. North Atlantic. It looks pretty peaceful. Some of you probably have this on your wall somewhere. Now let's look at what is actually going on in this piece of ocean. This is only the northeastern US. First, we'll add shipping. And this is AIS data or ship data from just a couple of years. And it's a heat map, and this whole thing is a heat map. The warmer the colors, the more activity there is. Now we're going to add mobile fishing gear. This does not include fixed lobster gear, which is why you see big empty spots on the coast of Maine. And it doesn't include gill nets. So the fixed gear for crab traps, sea bass, pots, lobster, hagfish, all that stuff is not included in this map. But what you can see is there's a lot of mobile gear activity, midwater and deepwater trawls. So there's quite a bit of it on the East Coast. All right, now we're going to add cables and pipelines. And that adds quite a little bit. And then we're going to add active lease areas for wind energy. Don't forget the military operations ranges. And so when you put that all together, this is the kind of thing. It's a little bit sobering to think about how much activity is actually underway in the ocean already. These maps do not include things like dump sites, sewage outfalls, potential aquaculture locations. It does not include the proposed seismic and oil exploration and the oil and gas drilling. In other words, this is probably about as good as it gets, and it's not going to get any better if we keep developing the ocean, which we're likely to do. And the other thing that's happening, of course, is that climate change is changing oceanic habitat, moving fisheries and shifting marine animal ranges and distributions. Whales and dolphins and really all marine animals will be going places that they have not been previously. Inevitably, there will be conflicts with industries that had not had to deal with those animals before. And so management strategies need to be much more dynamic and rapid and have rapid responses to changing animal locations. So, question 4, now that you're all thoroughly depressed, what can we do to make our industrialization of the ocean sustainable and more benign than what we have to date? So, although it's counterintuitive, we have found that it's critical for scientists to work with all the stakeholders, including the fishing industry, shipping companies, wind utilities, aquaculture facilities, to help them make their activities less damaging to oceanic health. So, for example, we've had excellent forward-thinking partners in the fishing industry working on alternative ropes that won't kill whales. This project out of the Anderson Cabot Center here at the aquarium is field testing reduced breaking strength sleeves in an active lobster fishery. The sleeves were invented by Massachusetts lobster fisherman John Haviland, and this picture is a picture of Mass lobsterman Rob Martin, and they're being tested as well by 7 other fishermen in Massachusetts and New Hampshire. And the idea is that, well, we can probably make ropes that won't kill whales, but if they can't go fishing with them, that doesn't work either. So the first step is actually to make sure that the fishermen can use these things in an operational fishery. And that's what we've been testing out there. We think these sleeves represent an option for some fisheries to keep fishing with a greatly reduced risk to whales. This option won't work anywhere. We've discovered that in really high tide areas or high current, high tide areas, they may abrade too quickly. And so we're thinking about options. There's technological solutions to that, but they're expensive. So this option won't work everywhere, but it might work in large sections of the US and in Canadian Atlantic coastal waters. There's also new technologies. When you think about the way we've been fishing in the world, pretty much been fishing with ropes for about 5,000 years. It's kind of old technology. So we and many others are in the middle of a variety of research projects to see if we can develop fishing gear that can be fished and retrieved without the use of ropes. And there are a number of challenges in this endeavor, but there are both American and Canadian fishermen who will be testing some of these approaches this summer. The fundamental idea is that you can have a trap on the bottom with a transponder and you can ping it with an acoustic modem and the trap comes to the surface and then away you go. And that seems like a pretty simple concept. The technology has been used by oceanographers for probably 50 years to retrieve millions of dollars of oceanographic equipment off the ocean floor. The difference is that in a fishing context, there's a lot of multiple fisheries occupying the same space. So you have to worry about conflicts. If the dragger doesn't see, the bottom dragger doesn't see the guy's buoys at the surface, he could tow through a lobster trawl. So those are the kind of challenges that are facing us. On the other hand, the power in your cell phone is enough that you can play Pokemon Go, right? And those things, those GPS Pokemons are anywhere you want to put them. And this is exactly how you could treat lobster buoys, and everyone could see them. So there's conceptual ways in which we could deal with the lack of transparency in the fishing industry and improve the technology. And, you know, it's going to take some software geeks to figure it out. But, and then the biggest challenge is really changing the culture of the fishery to really make them want to do this. And that starts with fishermen. Fishermen don't want to listen to me. They want to listen to other fishermen. On the ship strike piece, we lost a bunch of whales last year to ship strikes in the Gulf of St. Lawrence and here in the United States. And there are a bunch of well-tested options for reducing the risk of ships killing whales. Canada actually led the way on this with the first change in shipping lanes in the Bay of Fundy in the early 2000s. And they created an area to be avoided around the Roseway Basin area, which is a right whale hotspot on the Nova Scotia shelf. The United States moved shipping lanes in southern Massachusetts. That graphic or that chart in the upper left shows how the lanes were moved just a little bit to the north, just a few miles. It reduced the probability of encounter by 70 or 80%. And there are actually a bunch of dynamic management areas that are set in place when right whales are at the entrances of ports along the east coast of the United States, where ships coming out of those ports are required to go 10 knots or less. And it turns out that if you slow down to 10 knots, this is not rocket science. This is school zone technology, right? You don't drive through school zones at 60 miles an hour. You drive through at 10. If you drive through at 10, you're not going to hit anybody. And that's pretty much what happens with whales and ships. So 10 knots turns out to be a nice number that actually reduces the probability of whales dying by I think it's on the order of 80 to 85%. There's also a lot of work underway to determine methods for making ships quieter. We have some partners in the shipping industry and also multiple ports around the country. There's a bunch of solutions that appear to not only make ships more quieter, but they also make them more efficient and they emit less carbon. So it's kind of a win-win-win across the board. And a lot of shipping companies are looking at that because it's got economic value to it. And if we can make them quieter, all the better. So I just wanted to mention this. Last year, we had 12 whales die in the Gulf of St. Lawrence, 4 from ship strikes and 2 from entanglements. And I just wanted to bring this up because the two different the U.S. and the Canadians do things quite differently. And fishery management and transport management in Canada is actually done quite a bit more quickly than it is done in the United States. And they've stepped up with a broad response to ensure that all those deaths that happened in 2017 don't happen again in 2018. They're going to slow ships when right whales are seen, and they're going to close large areas to fishing when right whales are present. And they have 4 or 5 aircraft in the air right now transiting the Gulf and looking for animals. And in fact, in the upper left-hand corner of that yellow box, there were 76 right whales there the day before yesterday. So that, you know, all of us, and it's kind of, I mean, right whales are funny. It's like somebody turned the spigot on and they all pour in. And if you were paying attention this year in Cape Cod Bay, there were actually almost 250 right whales there in the springtime. And then they kind of spread out along the coast from Marblehead down through across the entrance to Boston and all the way down to Plymouth. And then all of a sudden they were gone. Literally 3 days it went from 150 animals to nothing. So they do seem to move relatively rapidly when the food runs out or when the spirit moves them. We don't quite understand that kind of coordinated movement, but it's pretty impressive. Given that we have climate change, ocean industrialization, changing distributions, and a pretty low power to detect trends, how are we going to make progress on this? So I believe that if we can make the case for the value of whales and dolphins and all marine life, a constituency for the oceans will grow. I believe that if we can show people what oceanic animals need for their home to be healthy and safe, that most industries will work to minimize their footprints in the ocean. I believe that nobody really wants to see an animal go extinct on their watch, and will make good faith effort to avoid that. And finally, I believe actually that we are really creative primates with the possibility that a combination of new technology, careful planning, and precautionary development based on strong scientific foundations can turn the tide of animals heading toward extinction. The Baiji, the vaquita, and the North Atlantic right whale all serve as early warnings to us. Their losses and the ongoing threats to the survivors are threats to everyone who works, lives, and plays on the ocean. And a collective view of how marine mammals are going to survive in an industrial ocean is really only beginning to emerge. On the other hand, if we can make our science-based stories of whales, dolphins, and other marine mammals show why they matter, what they need, and how we can minimize our impacts, the next generation should be able to bring a vision of benign coexistence between these animals and humans close to reality. Thank you.